Hello. So we're going to look at today directly proportional. And what does that mean? Well, two things are directly proportional. As one value increases, the other value will increase as well by the same factors. So if something were to double in size, then the other factor would also double if they were directly proportional. Right? Well, let's look at an example. So generally when I'm trying to think of examples myself so that I can help remember directly proportionals, things that are directly proportional, I think of equations in my head that I know for certain. For instance, did you know that a distance traveled equals your speed times the amount of time? So that's distance equals speed times time. That's a cool equation. Right? There's tons of others that you could use as well. Um, Common ones people use with density equations, area equals length times width. Any of those that'll work fine. So let's look at some things that are directly proportional here. Well, they will be directly proportional if as one increases, the other will have to increase as well. Okay, so let's say I am going to be driving on the interstate I-10. It's wide open, but I'm going to put it on cruise control just to be careful. I know that it's the speed limit set at 75, so I'm gonna put it at cruise control for 75 minutes or for 75 miles per hour. So we're gonna set our speed to be constant, meaning it's not gonna change because we're on cruise control at 75 miles per hour. Okay. How far would I travel in 1 hour? Hmm. So what is d when we travel for a time of 1 hour? Okay. Well, it's 75 miles per hour. So we've only gone 1 hour. That would have to be 75. All right. 75 miles. That's pretty simple. Okay. Well, what if we, instead of going for 1 hour, we went for 2 hours? So this time is at 2 hours. So for the first hour, we went 75. What do you think is going to happen the second hour? We're going to go 75 again. So we've gone a total of 150 miles. And that would be our distance that we traveled. Well, as this number, the time increases, what's happening to our distance? It is also increasing. Okay, so they're both increasing, but are they increasing by the same factor? Well, let's see. If I multiply 1 by 2, I get 2. If I multiply 75 by 2, I get 150. They're increasing by the same factor. Well, of course they are. We start off with this equation that distance equals speed times time. And the speed is staying constant. It's not changing. The speed will be the only thing that can cause this to go wacky. But the speed stays the exact same because we're on cruise control and we're just open road on I-10. So these two factors here must increase at the same rate. The same rate would be what the speed is. Okay, what about decreasing? Well, if we go for 2 hours and 1 hour, we would divide by 2. If we were to go from 150 miles to 75, we would have to divide by 2. It's working either way. As we go up, we go up. As we go down, we go down. So these two things are directly proportional. Wow, that's cool. Where's some other things that are directly proportional? As one goes up, the other goes up as well. Well, let's say the time stay constant. This is a constant thing for me actually. All right, I only have 1 hour to get kind of far. Well, let's start off slow. So let's say my time is I have 1 hour. And let's say I need to go a total distance of 1 mile. You're probably thinking, oh, you got plenty of time. That's right, I do. Let's say I'm going to use that whole hour driving behind the wheel. What speed will I have to go? if I'm going to get there in exactly 1 hour. I need to get 1 mile in exactly 1 hour. That's right. It would be 1 mile per hour. 1 mile for each hour or per hour. Okay, cool. Let's say, which is usually more common, I need to get a distance of 30 miles. And I only have 1 hour. What speed do I need to go on my car? I need to go 30 miles for each hour for 1 hour, or 30 miles per hour. So my speed would be 30 miles per hour. All right, cool. What if I need to go 75 miles? It'd be 75 miles per hour. Well, we look at, let me just put that one up here. So if we look at this, as we multiply this guy by 30, this gets multiplied by 30. As we multiply this guy by 2.5, this gets multiplied by 2.5. As this one went up, this one went up. As this goes down, this goes down. It's directly proportional. Wow. Yeah, it's directly proportional. That's right. As one goes up, the other goes up. This all came from the same equation, though. Well, notice that each part that we use is on other sides of the equation. That's why it's directly proportional, because the other thing has to stay constant. If we were looking at the same side, as this went up, this couldn't go up, because then this value would have to also go up, right? If we had 2 times 3, and if we made this 4 times 6, 2 times 3 would be 2 times 3 would be 6, and then we went to I said 4 times 6 we get 24. That number would go up by 4 times as much. It wouldn't be doubling. So whenever you are looking at directly proportional, if you were to set up an equation, you would have one number on one side equals, the other number on the other side equals. And notice how the constant, the thing that stays the same, in this case it was time, the last example was speed. The constant, the part that stays the same, always stays the same in every equation. Every time you do it with this format, it never changed. We set it at 1 hour. In this case, it stayed 1 hour every time. The last time we looked at speed, it stayed at the same speed throughout the entire problem. So let's say you're doing a directly proportional problem. And let's say that you see that as x doubles, y doubles. When x was 10 and y was 3. As x was 10, y was 3. And I want to write an equation for the relationship between x and y. I know that as x doubles, y doubles. So I know that x has to equal some constant times y. Some of you may be saying, where do these letters come from? They're just symbols, just like the number 1, 2, 3, 4. We will give them values. Let's give them a value. We know that when x was 10, y was 3. So 10 will be some number times 3. We also know that when x doubles, y has to double. So we also know that when x is 20, I'll just double 10, y would have to be 6. Well, let's see if we get the same constant value here. So what number times 3 gives me 10? Well, this would imply that the constant would have to be 10 divided by 3. How do I get that? If some number times 3 has to equal 10, then it must be whatever 10 divided by 3 is. Okay. Here we get a different equation though. We get that this constant must be whatever 20 divided by 6 is. Those aren't the same. I must have made a mistake somewhere. I'm sorry, guys. Oh, wait. No. These are both fractions. I can reduce them. If I reduce 20 over 6, we get 10 over 3. They're the same constant, so they're changing at the same constant rate. Isn't that awesome? I think it's kind of awesome. So if you ever had to create an equation based off the information that you had, you could do it. So let's change this up just a touch. Let's say that as let's not even do it that way. Let's do it this way. We'll say pressure is 100, then the temperature is 25. And as pressure was 50, the temperature was 12.5. Let's see if we can write an equation between the pressure and temperature. Well, when pressure was 100, temperature was 25, and when temperature was 12.5, pressure was 50. I can write this as a proportion between the two, or look at it as a ratio between them. 100 to 50 gave us 25 to 12.5, or the other way around. I set these equal to see if they're equal. Let's test them, see if they are. When I do 100 divided by 50, I get 2. When I do 25 divided by 12.5, I also get 2. Those are the same. That means that they must be increasing by the same constant. So these are directly proportional. Well, let's see what that equation would be. Doesn't matter which one you take out, but what we know is we have 100 is equal to some constant times 25. And many of you may be saying, hey, I know what number times 25 gives me 100. If you didn't, that's okay. You could divide both sides by 25 to find out what it is. So we will get 100 divided by 25 is whatever our k value is, or our constant. And in this case, our constant would be 4. We could then use that to solve other problems. So let's say I wanted to know, hey, what is the pressure whenever the temperature is 7? Well, I already know the constant is 4, so I could just do 4 times 7, so the pressure must be 28. That's pretty cool. We actually use this a lot in research. If I see that it's one thing increases, the other increases too, and I see it's the same constant factor, I can find out what that constant is, and then I have an equation I can create and continue to test against to see if it actually works. So that is directly proportional. Remember, as one goes up, the other goes up as well. And now you know how to use that to solve equations. Remember also, as one goes down, the other goes down as well. What happens when they go opposite directions? I don't know. We'll see you soon.